except now it's going to be in 2 dimensions rather than just simply 1. All right. So let me make a quick modification to this sheet. Okay, I'm going to shoot it from the angle south. Right. A car with mass 2,000 kilograms moving south at 5 meters per second is struck by another car with mass 2,500 kilograms moving east, moving at 6 meters per second. Hopefully everyone's okay. What direction, angle from south, does the 2-car collision move in, and at what speed? All right, so let's draw a picture. So we have a car which is moving south. The mass of this car is 2,000 kilograms. Right? It moves south and gets struck by another vehicle moving east. This mass of this car is 2,500 kilograms. Right? Moving east. Right? So this velocity v is equal to, let's call it m1, v1, m2, v2. v1 is 5 meters per second. v2 is going to be 6 meters per second. Okay? Moving in different directions. Right? So let's recall how we do this problem when we have 2 dimensions. Right? So we just have to break into the x component and the y component. Right? So what this means is that the initial momentum in the x direction is equal to the final momentum in the x direction, and ditto in the y direction. Okay? Oh, let's draw what the final state is going to be. So we're going to have 2 cars attached to each other, moving at some velocity in this direction, which we need to find out, okay, at some angle, right, from pure south. And this mass of the car, the final mass, is going to combine mass of these two, which is going to be 2,000 plus 2,500, which is equal to 4,500 kilograms. Okay, so let's do each of these components one at a time. So let's look at the x component first. Right. So in this case, let's write down the initial momentum in the x direction. So in this case, the initial momentum in the x direction is going to be the mass of car 2, right? Times v2, right, is equal to the final mass, which is m final, times the final direction in the x direction. Now I don't have anything for m1 because m1 is moving straight up and down in the south, and so in this case this just moves along the y-axis, whereas m2 moves along the x-axis. So therefore m1 does not play a role in the x component. Anyway, so this is actually enough to figure this all out. The x component is just going to be basically m2 is 2,500. The velocity is 6 meters per second. This is equal to the final state, which is going to be 4,500 kilograms times Vx. So this 25, so what you end up getting is Vx is equal to, this is going to be 15,000 divided by 4,500. And it happens to be, well, I'll write it on this side so it just becomes a little clearer what this is going to be. It's going to be 3.3 meters per second. Okay, so that's basically solves one of them. Now let's get the other component, the y component. All right. So to get the y component, same thing as before, basically. Let's look at the y direction. In this case, let's pick the y direction going this way. Well, let's pick the y direction going this way. That's y, that's x. Doesn't really matter in this case. Okay, so in this case, y, looking in the direction, is going to be m1 v1. That's the initial momentum in the y direction. That's going to be equal to basically the m final vy, which is something we need to find out. Vy is something we don't know yet. Okay, there's no m2 again for the same reason. m2 is moving along the x-axis, all right? And what we're curious about is basically stuff that's moving along in the y direction, right? So if it's moving along the x-axis, there is no y component in this case. All right, so the m1 is now going to be 2,000. v1 is 5, and that's going to be the 4,500, which is the final state, times vy. And if you actually figure this thing out, this happens to be probably about 2.2 times v which is equal to Vy. All right, so now we are done. Okay, so now let's look at this angle here. Let's just draw this thing out. So now we know that this thing's moving with some velocity Vy, and this is going to be equal to 2.2 meters per second, and it's going to be moving with some direction. Vx, okay, and this Vx is going to be Vx is equal to 3.3 meters per second. And we're interested in this angle, the angle for direct from south. So this angle here, okay. So let's draw out this thing. So this is actually Vx again, which is 3.3. And we want to figure the angle theta here, we require arctantric. Okay, so this is going to be theta is equal to the tangent minus 1, or the arctangent, atan, whatever how you like to describe it, of the far Vx over near Vy, which is equal to basically tangent minus 1. Whoops, let me just shift this up there a little bit. Of 3.3 over 2.2. And if you actually plug this into your calculator, what you'll find is this is equal to 56 degrees. Alright, if you want to get the magnitude of these two, then basically in this case, v, which is the speed, is going to be equal to the square root of Vx squared plus Vy squared. Alright, I'll leave it up to you to figure out what this answer